So how's this for an exciting network map that we're going to be playing with today? Two routers connected by a link. Here's what we're going to look at. Technologies that's existed for a long, long time. I'd never used it before. And it is basically, well, it's not basically, it is setting up a secondary IP address on a routed interface. And I'll tell you why I ran into this, why I started doing some looking into it, and what I found out. So here's the scenario that happened. Had an instance where I had similar to this, only they were SVIs, but an SVI that had a routed SVI, routed VLAN, set up in an HSRP pair with a uh, standby IP address. And the network that was the SVIs were assigned to was a /24. And what this network was used for wireless clients. So a wireless client would hop on the network. There were some helpers configured under these interfaces. They would go to a DHCP server and get an IP address to be on the wireless network. Well, what happened is this is configured for a /24, and eventually the pools ran out of IP addresses, and they did a bunch of back-end tweaks on the pools to reduce lease time, et cetera. But it was just too many clients needing to get on the wireless network, and the scope wasn't big enough. So we had to increase the size of the scope for the wireless clients. Um, did not want to. I mean, the first thing I thought of course, was okay. Well, let's get rid of this 24 and just replace it with a /23, which would give them twice as many IP addresses. But that would be disruptive to the clients, people that were on the /24 network that existed right now. When we rolled it over, they would be interrupted, have to send out service bulletins, all that kind of stuff. So I wanted to look at another option that would allow the people that were on the wireless network to continue to be on it without interruption, but allow them to get more people on it. And the first thing I thought of was setting up a secondary IP address on the interface. Now, I didn't know much about secondary IP addresses. I knew they existed, I knew you could do them, but I had never used one for any practical purpose at all. And wanted to look at that option because I figured if I could keep the existing network, in this case the 10.1.10.0.24 network, in place, but just add another /24, it wouldn't be disruptive to the client, and the change would actually be pretty easy. So I had two major concerns with doing this. Number one, so my first concern was, if I set up a secondary IP address under these interfaces, what does that do to DHCP? I mean, knowing how, again, like I said, these interfaces were actually configured with IP helpers. Knowing how IP helpers work, it broadcasts based on the primary IP address on the interface. So what's going to happen to DHCP? Say the primary interface scope fills up. How does it? How do clients that would be in the secondary IP space? How do they get? How do they get an IP address assigned to them from a DHCP server? So did some poking around with Cisco and found out that Cisco does indeed have a command that will take care of that concern. When you have a secondary interface set up, uh, a secondary IP address set up on an interface, there's a global command that you can enter. And let me put the command on the screen here first. So the command is IPDHCP smart. You see how great my typing skills are. Relay. So that's a global command, IPDHCP smart relay. And here's what that does. I'm going to read right from the text here. If that command is configured, the relay agent counts the number of times that the client retries sending a request to the DHCP server. When there are no DHCP offer messages from the DHCP server, after 3 tries, the relay agent, or the switch or the router in our case, the relay agent sets the gateway address to the secondary address. So basically, someone comes in, it sends to the gateway base, or to the DHCP server, using this as the IP address. If it sends 3 requests out and it never receives an offer, it flips over and sends it out using the secondary IP address. Thus, the DHCP server would pick it up on the scope you set up for the secondary IP address and assign it a lease. So that solved my first question. My next concern, after finding that out, is the fact that this is set up in standby groups. And not only would I need to be able to configure a secondary IP address on these interfaces and make sure the DHCP works properly, also need to make sure that HSRP works properly too. So again, hopped on to Dynamips here and mocked this up and started playing with secondary IP addresses and HSRP groups and found out some very interesting things. So I thought I would whip up a little tutorial here looking at those options. And I just wanted to give a little story as to why I would even start looking into such a thing. So here's the first thing we're going to do. I got two brand new routers set up, R1 and R2, no configs on them. So we're going to go in, they're connected on F00. We're going to go in and configure it like we see here with a normal IP address like we always do. Set up HSRP, set up preempt. We'll make R1 the priority or the master for the group. Verify that our HSRP is working. And then we're going to set up a secondary IP address on this interface and see what that does to our HSRP to HSRP. So let's get started here with router 1 first. So let me go down here and bring up router 1. Make sure that I don't have this configured. I'm pretty sure I don't. Okay, so we're going to use fast00 because those are the ones that are connected. So we're going to go to config mode, interface fast 0/0. It's already up, so we're going to go IP address 10.1.10.2, and we'll put it in a 24-bit mask. Alright, so there's our IP address. We are going to put it in a standby group, so let's go standby group. We'll call it number 10. The IP address 1.10.1. So that's the virtual IP address that we want the group to use. Standby 10. We're going to make this one a priority 105, so it will be higher than the default of 100. So this one should be the master, as long as we set up preemption. And we're going to set up preemption. We'll say delay minimum. Let's just make it 15 seconds so we don't have to wait for a long time there. And I think we got everything. So let's just check what I had configured back here. We got the IP address, the standby, the priority, and the preempt. So there's router 1 configured with its virtual IP address of 10.1.10.1. There's the real IP address. Priority of 105, so this one should win, and it's going to preempt after 15 seconds. So let's go over to router 2, set up that as the second member of the HSRP pair. IP address 10. Now this one is going to have a real IP address of 10.1.10.3. And we're going to do a standby 10 IP 10.1.10.1. Standby, we'll do a preempt on this one. Delay minimum, we'll use 15 seconds. But we're not going to change the priority. We're going to leave this at a default priority of 100. That way R1 should become master for this group. So let's do a show standby brief. And the other one is unknown. So we'll let it. There we go. Okay, so here we are. This is from router 2's perspective. Router 2 has a on standby group 10. It has a priority 100, which is the default. Its state is the standby. It's the standby router because of its lower priority. The active router is 10.1.10.2, which is this guy over here, 10.1.10.2. The standby router is a local, meaning that router 2 that we're on is the standby router, and the virtual IP that they're serving is 10.1.10.1, which is what we configured right here, 10.1.10.1. If we go to router 1's perspective, we should see just the opposite. Do show standby brief. So from this router's perspective, for group 10, there's priority 105 because that's what we configured router 1 to have a higher priority. The local router is the active router. The standby router is .3, which is what we configured this one to be, .3, and the virtual IP is 10.1.10.1. Now, let's go and add the secondary IP address to this interface. So we're going to go IP address 10. Let's change the third octet. 1.20.255.255.255.0, and we're going to add the keyword secondary behind it. So now this interface has two IP addresses, a primary and a secondary. We're going to do a standby group 20 IP address of 10.1.20.1, because that's the virtual IP address that we want the HSRP group to use. We're going to do, we're going to let the other router 2, have the master role on this one. So we're not going to set a higher priority. But what we are going to do is say standby 20 preempt delay minimum 15 seconds. Okay, so that should be it for router 1. So let's do a show run interface fast 0/0. Make sure we got the secondary IP addresses and the two HSRP groups, which we do. Alright, now if we do a show standby summary, what do we see? Show stand summary. Brief. Oh, it's brief. No wonder it's not working. Brief. Okay, so this is telling us from its perspective it's got a priority of 100 because we didn't configure a higher priority, so it's using the default. And it's the active router. It can't find a standby router. And the virtual IP address is 10.1.21. It can't find one because we haven't configured one yet. So let's hop over to router 2 and do the same thing. Go back into that interface, fast 0/0. IP address 10.1.20.3. And we're going to put the secondary keyword behind that one as well. What did I mess up? IP at, oh, too many D's. 10.1.20.3. Secondary. Okay, so that one has a secondary IP address as well. We're going to do a standby group 20 IP address 10.1.20.1, same as we configured on router 1. We're going to go standby 20 preempt delay min 15 seconds, so it'll take over in 15 seconds. And we want to make this one the master, so we got to give it a higher priority than the default, which is 100. So we're going to say standby 20 priority 105. So it'll have the higher priority. Alright, so we can see already something's flipping on over here for group 20, which is the one we just configured, is flipping over from speak to standby. So let's show standby brief. And okay, now we can see that from this router's perspective, okay, there, it just flipped over. The preemption kicked in, the 15-second preemption kicked in. It's having some problems here. It still thinks that the local router is playing the local role, and the standby is unknown. So if we let it refresh, here we go. So look at this. One physical interface, fast 00. We've got two IP addresses on it, and but with two different routers taking the master role based on the IP address that we configured. So for our standby group 10, which we configured to have the virtual IP address of 10.1.10.1, this router 2, is in the standby state. Router 1 is the active. And the state of this router is the standby one is a local one, or router 2. The active router is router 1, and the state of this router is in standby mode. For group 20, which is our secondary IP address, 10.1.21 is our virtual IP address, which has this router has a priority 105, so it's the active router. The state is active. The active router is the local one, or the master. The standby is 10.1.21, which we configured to be R1. If we flip over to R1, we're going to see just the exact opposite. So show standby brief. Okay, so here we see just the opposite, because on router 1 we configured group 10 to have the priority 105. Its state is active. It's the active router. The active router is a local and the standby is router 2, and there's the virtual IP address they're serving. For group 20, we left it at the default of 100 on router 1, so its state is standby. It's the standby router. The active router is 20.3, which is router 2 over there, and the state is the local router. The standby router is this one, and here's the virtual IP address that it's serving. Now, one of the weird things you will see about, well, let's just do this. I'll show you some of the weird things you see with when you do secondary IP addresses. So let's do this first. I'll show IP interface brief. It only shows the primary IP address. You don't know that there's a secondary IP address configured on this interface. So that's one thing. Show IP, what do we do? Show IP route. What do we see here? Okay, here we do see that the second IP address that we configured. Now here's a code L. If we look up here, what is L? L means it's local to this router. C means it's connected. Okay, so that doesn't tell us a whole lot of information. Here's the other thing that you see. If we do a debug, and in this case, let's do standby, and let's do packets. Now we're going to see some HSRP packets going on, and we'll let a few go by, and then I'll stop it. Okay. Undebug all. Now, we see the .20, which is the secondary IP address on fast00, and here we see .10 on fast00. So this could potentially be confusing to someone who comes into this router and isn't aware of how it's configured. Secondary IP addresses don't show up everywhere. They show up on some of the debug outputs. They'd show up in the routing table like we just looked at. But when you look at the interfaces with a show IP interface brief or some summary command like that, and you don't see a secondary IP address configured on the interface. So you got to go look at the interface itself and be aware of that. So again, that's a case where your documentation would be very important. So again, that is just a quick look at setting up a secondary IP address on a routed interface, why you may want to do that. My little scenario is probably one of many hundreds of reasons why you'd want to do that, but it works. Again, keeping track of any secondary IP addresses is a documentation effort. You got to make sure your documentation is up to date. And then in my particular case, or the reason that we looked at this, the whole thing was kicked off because of this command right here. Again, because of DHCP, when you have a secondary interface, and when you have this command enabled, and you have a secondary IP address configured, and say we had helper set up. They're not in the config, but say we had IP helper set up. So the IP helper, it forwards the request to the IP helper based on its primary IP address. If it does not see a DHCP offer come back from the DHCP servers after 3 tries, it will start sending them to the DHCP server based on this IP address, the secondary IP address. So again, a combination of using the smart relay in DHCP and setting up secondary IP addresses got me out of a little bit of a jam, made my life a little bit easier. So I wanted to share that with everybody. Hopefully it'll help you out too. Take care.